honor given to me to be in front of you to talk about the cost of machining in machined jobs. Earlier the topic given was making realistic cost estimation. Now it seems to be a zero-based costing methods. Let me go according to the earlier topic. Of course, there is no much difference between that. I will tell you in the last what is the major difference. I personally feel that it is definitely a required subject today in Tiruchi to talk about the machining cost, because Tiruchi is concentrating or specializing more on fabrication work. First of all, this is my personal opinion, that cost for machining should never be talked about in kg basis, like for fabrication, for obvious reasons. Of course, there are different viewpoints in this subject. You can also quote on kg basis for anything. I remember the jig boring machine in building 5 BHEL was purchased on kg basis. 3-wire method measuring instrument in the metallurgy was purchased in kg basis. But those were purchased with a specific calculation, or they have arrived at the basic or kg basis based on some calculation. But the skill for arriving at that cost per kg is no longer existing. Of course, even today we can calculate it. It is not that it is impossible, it is possible. But generally, there cannot be a direct comparison for a machining job on kg basis. That is one thing is very clear. There are numerous machining processes available today, right from cutting of material. You can cut it by any method. There are 100 methods available. Then basic, if you go into the detail of machining, it's cutting, turning, milling, boring, etc. For each operation, we can arrive at the cost. Now, next slide. To determine the product or project cost effectively, we should know what is the machining process, manufacturing process to be adopted. With the time duration very short, let me not go into the detail in full. See, for example, if you want to make a thread, to what accuracy you want to make a thread, what quantity is required, what is the configuration of that component, what is the weight of the component, so many things have got to be considered. To make things simple, let me take an example of a tie rod, because most of the people in Trichy know about tie rod. It's a rod with a thread, metric thread of various lengths. The length may be 700 mm or it may be 6.5 meters or 12 meters. The thread length may be say 250 mm, M72 into 6 mm pitch. That's okay. Because the particular area where you have got to machine is the same for both the components, that doesn't mean you can have the same rate because of the length, handling, configuration, weight, everything. I will take that slide and then tell you how we have arrived at the cost and what process is the best. The very first thing for any manufacturing is material preparation. Material can be prepared by gas cutting or saw. If you say saw, it may be a reciprocating saw, it may be a band saw, it may be a circular saw. Then RCA steel cutting or plasma cutting and water jet cutting or laser cutting. This is the basic material preparation. The next comes metal removal process by way of lathe, horizontal boring or vertical boring, etc. Then next comes milling, drilling, vertical or horizontal boring, threading, internal or external. Now these are the processes. As I told you earlier, the cost depends on the configuration, overall size, weight of the component, the features, tolerances and finish required. Then naturally the quantity. You take for instance an M24 into 100 mm threading. If it is done by process A, it is going to cost some X. Process B, definitely not X, it is different from X. Process C, D, E, F. Suppose if you have a quantity of 3 numbers only, you have to select the process, what type of machine you are going to use. If it is 350, what is the machine, the process? If it is more than 350, what is the process? Simple example, a proven example available in any handbook is, if the quantity is 3, the best process is proved to be an ordinary engine lathe with a single point tool. The component remaining the same, if the quantity is up to 350, a cast iron or a curved lathe is proved to be the most economical. And once it goes beyond 350, the semi-automatic is supposed to be the most economical. Though, apparently, the cost per piece for that component, if done in a central lathe, is 24 rupees 92 paise, whereas for the same component, because of the quantity and because of the work center being an semi-automatic, it is going to cost only 97 paise. We have got one proof for that, proven records. Now, day before yesterday in the Hindu, the Executive Director of BHL, Mr. A.D. Krishnan, has very rightly and very a timely statement he has given that the cost, designed to cost, is a very, very apt word, and it has got to be emphasized today that the cost of that component mainly depends on the design, and the designers should have an open mind for any deliberation for cost-effective change in design for cost-effectiveness of the component. Now, basically the cost is comprised of the machine hour cost, fixed cost, labor cost, overheads. The total component cost is material cost to labor cost plus overhead. We have taken an example of 2 items. One is a bandsaw. Bandsaw is available right now, exhibited by Sunmac. There is a way of calculation, it's a proven, authorized, approved way. The machine cost, then life of that machine, then interest rate and the salvage value. And how to arrive at that fixed cost is available here, and the interest on salvage is taken, and the operating cost is based on the power consumption and the repair and maintenance. If you add up that, it works out to 9 rupees 87, say 10 rupees per hour is the, what ultimately anybody here, a small machine shop need to know is, how much is bandsaw is going to cost per hour? Is 10 rupees per hour. Is that all? No. The next comes the labor cost. The labor cost is again converted into mission hour. This also can vary based on the number of hours of machine engagement. Is it going to be worked for 1 hour, 1 shift basis or 2 shifts? Now, if you see it is 25 rupees, then overhead is the administrative cost, equipment cost, building cost and office supplies. There is a figure for that. If you add up all these things, it comes to around 40 rupees. Plus, there is a variable cost on blades, which mainly depends on whether you are going to cut an ordinary IS2062 or low alloy steel material 739B11 or very high alloy steel material. Based on that, the tooling cost will go up or low. That blade cost also depends on the number of cutting and the blade material, whether it is a carbon steel blade or a bimetal bandsaw. Now, I have taken a simple example. It's a practical example. This item is a SA387 grade 11 material, a pad plate coming in the top suspension. Now it's a plate welded on to both ends of a longer suspension plate. Now, normally, because of the quantity I have taken this example, if you cut it by the profile cutting, CNC profile cutting by a off-CS clean flame, and you can see that 71 dia is to be bored because the pin is going inside, there's a tolerance. There's a cost coming for that. Instead, if the same component is tried by a laser cutting, which we have done it, the cost is coming down. You can see how. Now, the details of the cost working is given. And by RCS plane, it works out to 72 rupees per piece, 79 rupees per piece, whereas by laser cutting it's 72. There is no boring involved because the tolerance level you are getting by laser cutting is less than 0.1 mm and the positional accuracy is very good. So here you will have to select the process to arrive at the right cost, optimum cost. Now the second is the famous tie rod or a hanger rod. And here 2 examples are taken. One is by ordinary engine lathes, another is by thread chasing machine. And you can see definitely thread chasing is much faster, much lower cost and repeatability, less operator skill. Everything is there and the details are given. And it is almost 50%. I think Mr. KG Muralidharan will vouch for this. Next. Now, one more point, Mr. Ravindran, while he was talking, he was telling about the training given to various people in various areas. I think glaringly the area of skill development machining is missing, which I request Mr. Ravindran. So, because we are here talking about machining, that is obviously it's missing and it should be. Now, personally or on behalf of Adroit, we can offer the services of giving training from the basics for all types of machines, whether it is a bandsaw, hacksaw, milling machine or atomic boring, lathe, CNC, because we have all the machines and we have all the equipments also. I would like to offer services to be a part of the training program, because this is where we can offer our extend our